There we go, quadratic equations. That's the topic for today. Ax squared plus bx plus c. We're going to talk about the fact that it is a function that passes the vertical line test. We're going to talk about what a does, what b does, and what c does. All three of them have certain characteristics that we're going to use, whether you have a calculator or not have a calculator. Right now you have the quadratic program. That's for this situation, ax squared plus bx plus c. That's for solving. Opposite of b plus or minus square root b squared minus 4ac over 2a. Those are the x-intercepts of a quadratic graph. Okay? That's what it means. Y equals 0. It's a quadratic graph, and those are the x-intercepts. So you have a fast way of finding the x-intercepts. You have an even faster way of graphing it. Then we're going to talk about how it changes. So it should be a lot of fun. Not going to ask a lot of things, but anyway, let's see. If b and c equals 0, the vertex of the parabola ax squared is at the origin, and b equals 0. I don't know what that means. Oh, here we go. Ax squared, a, b, and c, we talked about that. B equals c equals 0. The a, I call it the amplitude. It doesn't really have amplitude, but that's the vertical stretch and compression. That's how you stretch something vertically. Remember, if a is greater than 0, actually, let's do this. The absolute value of a, if it's greater than 1, it's going to be a stretch, or it's going to be skinnier. Okay? It's going to be a stretch, or it's going to be skinnier. I don't know how you want to look at it, but it's going to be skinnier. If you have 4x squared, it's going to be a lot thinner than if you have 1x squared. If a is a fraction, if a is between 1 and 0, I'm using absolute value right here because we'll talk about the negative in a minute. If it's a fraction, it's going to be a lot wider. And we did that the other day with our graphs. It's going to be wider, or it's also known as a compression, a vertical compression. Okay? So that's what A tells you. It's also at the origin if there is no B or C, but that's kind of boring. C. Yeah?
When is it a horizontal compression?
Oh, that's when you go inside the squared. So if you went like 1/2 x squared, that'd be like a horizontal stretching, okay, or a horizontal compression. That works just the opposite, actually. Okay? But yeah, that would be inside of it. It gets wider if you have 1/2 x squared. That's a horizontal. Oh, C. That's outside the function. Okay? The base graph I'm using for this is f of x equals x squared. You know, the standard garden variety parabola that everybody has, you know, those lawn ornaments in the yard. Y equals x squared. You see them all over the place. If you add C to it, it moves that graph up or down. Okay? Sure. I mean, it's outside the function. It moves it up. It's a vertical shift. If you put an A in front of it, and then you're talking, is it wider or is it skinnier? The reason you have to know these things is, one, your next math class, you might or might not be able to use a calculator when you're graphing these out. Two, you have to know, because questions won't be asked in such a deliberate fashion. They'll say, give an example of a parabola that has these qualities, and you have to work backwards. So that would be a for instance. Okay? You can't always type everything out, is the short of it. All right. I like that. Very good. What's this say? Oh, complete the square, and you have a standard equation of a parabola. Does the HK look familiar to you from anything for the standard equation? Where did the HK come from in the standard equation? Come from what? Let's go to that side of the room. Where does it come from, the HK? Well, yeah, but where have you seen it before? Yeah, the center of a circle. We said x minus h squared plus y minus k squared equals r squared. Well, look, that's the center of a circle. That's the point of interest, the center. Here, That is the center of the parabola, the vertex. The vertex is where things change. Instead of going down, you go up. Instead of go up, you go down. That's the vertex. So it has the vertex at small h, small k. And you find the vertex by completing the square. Or, if you know calculus, bam, one step, you got the vertex and you're moving on. But we don't know calculus yet. Okay, so the vertex is shifted up or down k units, thereby giving you the center of it. Do you remember completing the square on the vertex questions before? Hopefully this is just review, right? You've had this before, the standard equation? Yeah. Okay, good. Perfect, because I wasn't going to spend a lot of time on it. Yeah, b not equals 0, c not equals 0. Good. So in this one, find the standard equation of any parabola that has a vertex v. V is at 4, -2. Oh, it says any parabola. What do you think any means? Any parabola that goes to that vertex. So the vertex is going to be at 4, -2. 1, 2, 3, 4, 1, 2, dot. Any vertex you can think of. I'm thinking of one like this. That is a wide one. It takes up a lot of space. Which vertex are you thinking of? Up? Well, how in the heck do you write the equation of any? Which one are you thinking of? The same one? That's you just said that. You're thinking of one? You should be thinking of one like this. Nice. How do you write the equation of any parabola to that vertex? You look like you're deep in thought. What do you think? You know what the H is, right? You know what the K is, right? Good. Right, so you write f of x or y, x minus 4 squared. Yeah, minus 2, because you're down 2, right? And what about the any parabola? That's a specific parabola. That parabola is the one in red. How do you make it so it becomes blue or green? A. Hey, you just put the A right there. A is what drives a parabola. It either opens up if A is positive. If A is positive, it opens up. If A is negative, it opens down. In calculus, we call that a minimum, and we call that a maximum. Just by looking at the question, you already know if you're going to have a minimum or a maximum y value on your parabola. You guys must have already known that. That's fantastic. Did you know that? Yeah. Excellent. So you guys are with cubes, and we're in good shape. Why was well, never mind. All right, how did you complete the square on this one? What's the vertex of this, just by looking at it? Do you not complete the square? A one-sided completing the square. How do you complete the square on one side? Oh, sorry. I thought this was all review. Over there. How do you complete the square on one side? You remember I always put that plus blank? Right? But I used to always put it on the other side, and I can't. I put the minus blank. Is that what you're going to say, Alex? Yeah, you can do that because the 11 works. Now, the only problem with that is you have to be careful. You have to make sure it is positive. If it's a minus 11, some people get caught doing that because the third term has to be added. That makes sense? Okay. Yeah, you can do that, or else I can just cut it in half and I can square it. So I'm going to add 9 and subtract 9. How can you add 9 and subtract 9 to an expression without changing its value? Yeah. Yeah, you're just adding 0. There was an identity. You had a rule for identity in algebra. A plus 0 equals A. 0 takes on a lot of different forms. Not just 0. That's boring. So in this case, you get the idea. So you have x minus 3 squared plus 2. As Alex said, that's a parabola with, over 3 and up 2. Is it open up or down? Up. And A is equal to 1, so it's a normal width. Okay? Fantastic. All right. Completing the square on both sides, you're just adding 0. Moving on. Maybe I'll get this whole thing done. Should we do another one, or you got the idea? This one's a little bit more difficult. This is more like a test question. Should we go through it? Let's go through it. We're here, we might as well. See, I do the same thing every time, so I'm really not, I see that there's a -4. When you complete the square, that has to be a what? Yeah, it has to be a 1. And you're still in pre-calculus, so those numbers are going to be nice to work with. So I look at it, as a lot of other people do. I still do the plus something and the minus something. Okay? I still do the plus something, and I still do the minus something. Remember, you have to add 0 to it. The only reason I took the -4 out was I wanted the 1 in front of the x squared, right?
Yeah.
And now it looks just like the last one. I'm going to actually divide by 2, square it, end up with a 4. So far, so good? Is everything okay? Good. But what did I actually add? Yeah, I actually added the -16. So to make it 0, I have to make this one a plus 16, don't I? That's 0, isn't it? If I added a -16 on the left half of the expression, I have to add minus a negative. No, wait a minute. Yeah, but I changed it. I had my sign there for negative. So I have to put a plus 16 in the blank. There we go. I feel better now. Now I think I'm ready. I have a -4. I have an x minus 2 squared with a plus 3. That equals f of x. Because since I actually added a -16, I have to add a positive 16 for the 0. So this parabola has a vertex at 2 and 3. Which way is it going to open? Down. Is it going to be skinnier or wider than normal? Skinnier, I think, isn't it? By a factor of 4. Or you could use fancy words like a vertical stretch. Is that fancy? They use something else, don't they? Compressions. Maybe they use stretch. Vertical stretch of a factor of 4. All right. I like those questions, especially when the numbers work out nice. Any questions on that? Okay. All right. What's this? Oh, these are what all the letters stand for. I don't know if you remember them or not. But the axis of symmetry, that's a vertical line. It cuts the parabola in half. It is the opposite of b over 2a. That's how you find the equation for the axis of symmetry. It's no coincidence it comes from the quadratic formula. You know the opposite of b plus or minus la-di-da-di-da all over 2a? That's where it comes from. The opposite of b plus or minus square root of b squared minus 4ac all over 2a. It comes from this part right there, the opposite of b. Next, the x-coordinate of the vertex. Again, the opposite of b over 2a. Well, there's no mistake about that. Opposite of b over 2a. In calculus, we do something even quicker than that. That's a lot of fun. The y-coordinate. I don't know why people don't get this. If you know x, how do you find y? Yeah, you put it into the equation. That's what this says. Put x into the equation. Yeah, put x into the equation. And it works out. This is probably just a reminder. If a is positive, it opens up, and we consider that to be a minimum. We've already talked about that. If a opens down, we consider that to be a maximum, and we looked at. Make sure you know I'm talking about the minimum y value and the maximum y value. Okay? Not just any old y value, but the minimum or the maximum y value on the entire graph. And the x-intercepts can be found by factoring or using the quadratic formula. Okay? At Parkland, I don't give them the quadratic program. If a student has it from high school, I let them use it. So if you guys would ever go there, they would probably let you use it. But that's why it's not mentioned here. But instead, I'd use the quadratic program. Okay? Like I said, that's probably just all review. That way, when you take the test next week, you should do pretty good. Questions? How am I doing on time? Excellent. All right. Find the zeros of f and find the maximum or minimum of f of x and sketch the graph of f. This is really cool. Use a quadratic formula to find the zeros of s. Okay? We have that, don't we? We just have it typed in here. If you want to go old school, that's fine. If you ever think you're going to forget your calculator and you want to go old school, go ahead. Me, I always have my calculator here with me, so I don't have to worry about it. -4, 4, and 1. Program. Quadratic program. -4, 4, -1. And what do you think that would be? 0.5 and 0.5. What is it? Yeah? No? If I have this, that means when x equals a half, the equation equals 0, right? Twice it happens. But if I write x minus a half times x minus a half, if I multiply, it doesn't give me -4x squared. Does it? 2x and 2x. Well, no, some people look at it this way. 4x squared minus 4x plus 1. You know, the negative out in front is going to make the parabola go down. So they don't factor with the negative in it. So from the answer of the calculator, how do you think you'd write those factors? Yeah, 2x minus 1/2, and well, that's kind of 2x minus 1 squared with a negative out in front. What's another name for the 1/2? What can you expect from the graph before you punch it out? What's the 1/2 of the 1/2 tell you? There's only one x-intercept. But there's supposed to be two things that make it equal to 0. Aha! The double root rears its ugly head. See, if you have a quadratic and it hits twice, that's two distinct zeros right there. If you have it and it bounces once, that's known as a double root or a tangent. That's what we have here. We have a tangent. And if you want to complete the process, it's going to be at 1/2 and 0. So you can go to 1/2, 0, make a dot. Is the graph going to open up or down? Down. That's going to look something like that. The reason I bring it up is that's the vertex also, isn't it? Which is also the maximum y value. So in one problem, you find the maximum and minimum, and you make the sketch because you see that that's going to be a double root. That happens anytime you have two values of x of the same number. If you're not sure, we'll type it out. Y equals negative 4x squared plus 4x minus 1. There you go. Ooh. How do you think you'd find that point if you were looking for it? Intersection doesn't work on a tangent graph. Intersection doesn't work. How do you think you would find it? Maximum. Second, calculate the maximum. That's why I have to know ahead of time. Are you looking for a maximum or are you looking for a minimum? Now it wants to know left bound. What do you think that means? A number to the left. An x value to the left of your vertex. So I picked negative 8. If you really have no idea, just Google it. I did maximum. Second, calculate maximum. Yeah, Google it. I go to the very ends of the earth. Well, ends of the screen, actually. Like I put negative 10. Right bound, I'd put 10 because I have no idea. And my guess is 0. All it wants is a place to look. So if I really have no idea, I'll just go negative 10 to 10, the width of my whole screen. And some kids said, oh, you're like Googling it. Sure, whatever. Okay. But I told the kid I'd use it once. And there you go. Look at that. What does the Y display mean, though? What is that ugly number? Negative 2.34 e negative 11. What's that? Yeah, negative 2.34 times 10 to the negative 11. How does that correspond with what we know is 1/2 and 0? Does that look even close? Oh, yeah, it does. 0.5 is the x. And this means negative 2.34 times 10 to the negative 11, which we call 0. That's a calculator way of defaulting to 0. You have to be able to read that if you're going to run this calculator. You okay? Some do, some don't. Okay? What? It didn't? Why not? That's because your window's not set up to go from negative 10 to 10. Go to Zoom 6 and you can set it up that way. Remember, I just went to Zoom Standard probably and did that graph. Okay? Anything else? Look at all that stuff just on one graph. You got the minimum, you got the maximum, you got the quadratic program, you got the factoring, you got the picture. Anything else? Well, we could do the quadratic, but that's okay. Ready to move on? I'm ready to do more. Find the standard equation of the parabola shown in the figure. Well, that means I have to come up with the equation. Have you guys done that a lot? What's the best way of doing it? I always just do it the same way. The same old boring way. I'm looking for something new, something fresh. What do you got?
I got nothing.
You got nothing?
I got nothing.
It's kind of like finding the equation of a line. I was very impressed that everybody in the room got that right on their assessment, and then I saw today I actually did it in the notes beforehand. So if you wrote it down, then you were in good shape. That was my fault. But anyway, yeah, I figured it out. The vertex, this is H and this is K. Wait a minute, we had H and K before, didn't we? And what didn't we have for the family of parabolas? What were we missing? You remember my parabola, the wide blue one? His parabola, the one going up? We were missing A. So if you're given H and K, you can use this X and Y, and with all four of them, you can use those to find A. And should A be positive or negative? Positive. That's what we're going to do. The equation is f of x equals x minus negative 1 squared plus negative 2 with an A. You get that from the vertex. Given a point, I'm now going to find A. So my y coordinate is going to be 3. That equals A times 2 plus 1 squared minus 2. All I'm going to do is solve for A. Just like the line, I used x, y, and m to find B. I'm using h, k, x, and y to find A. See, it's boring. It's very systematic, very effective. I want something different. Well, I'll come up with it later. You like? Yeah. There's a better way, but I can't show you yet. That's 9, right? Divide it over, you get 5/9 equals A. That's an odd answer, don't you think? 5/9. Yeah, what are you going to do? It didn't ask to be 5/9. It just came out to be squared. What was B? -2. Does that look right? Did anybody check it? You didn't check it? Well, if I put in -1, do I get -2? Yes. If I put in 2, do I get 3? 9, 5 minus, yeah, I get 3. That's about all you can do. Do you want to check to see if it's a parabola? I already know it's a parabola. It has something squared. I know it's a vertex. You could guess points over on the other side if you wanted to, if you want to take a guess. That's all you'd be doing, getting close. I bet if you put that in, you'd be pretty close to the answer. 1, 2, 3, 4, 5, 6, 7. But you have to have a window from 7 to -7 to take a look. Okay? Somebody in the room will do it, and I'll find out if we're close because they'll say, we're not close. But, yeah, I think we're all in pretty good shape. Yeah, their window's -7 to 7. Okay? Find the standard equation of a parabola that has a vertical axis that satisfies the given conditions. What the heck does that mean? Quadratics have an axis of symmetry. And what type of line is that axis of symmetry? Vertical. A parabola, don't forget, could also be a sideways. It could be a y squared. They're telling you it's not. They're telling you it's a vertical axis of symmetry, so it's a regular parabola that you can find pretty easy. Why don't you give this one a shot, and I'll see if we can do it. In calculus, we work with other parabolas. So they're making the distinction right now of how to tell you the difference. H and K, X and Y. What do you get for an answer? What'd you get? Same thing? What'd you get? Same thing? What'd you get? Nice. It must be right. Any questions? It's not too difficult now once you get the hang of it, is it? If you can find the equation of a line, and you can find the equation of a quadratic, I just remembered something. How much time do I have left? Excellent. I like this. I haven't thought of this in years. X and Y. I need, I don't know, 6 X's that generate different Y's. Give me an X value. 5. 5? Okay, what's the Y value? I'll be back. Give me an X and a Y. What? Let him finish. What is it? 5 and -45? Okay. Is that right? Okay. Give me another one. 3 and what? Gee. What is it? Negative 13. What? Okay. There's a 1 better than that, but nobody's picked it yet, so 1 would be what? 3? 0 would be 5, wouldn't it? I need 1 more. 2 would be what? Negative what? Negative 3. Okay. So there's my information. This shows you, given a set of points, how do you know if it's a quadratic? Because somebody might show up one day and ask you to do that, like me next week. So, how do you tell if it's a quadratic? I think this is right. I could be wrong. Let's see. You go in numerical order. 0, 1, 2, 3, 5. I hope this works. 5, and then 1 is 3. 2 is negative 3. 3 is negative 13. And 5 is negative 45. All right. 5 minus 3. I think you go that way is what? 2? 3 minus the negative 3 is 6. Negative 3 minus negative 13 is 10, right? And negative 13 minus 32? Is it? Okay. Oh, I need a 4. Ooh, that was close. What's the 4? I could do it with a 5, but I don't think you get it. So 3 was negative 13, and what? Negative 27? Okay, what's the difference between those two? 14? And 5 we said was what? Negative what? 45? And the difference between those two is, what is it? 18. So the second difference is what? 4. That's the quadratic is the only one that has a second difference the same. No other family of functions has that unique characteristic. So that's the second one, the 4, the 4, the 4, and the 4. The second difference is the same when you generate x and y values for a quadratic. That's interesting. That just goes to show you how the book's getting easier over time. This was my first pre-calculus book. You had to go through all these points and figure out they were quadratics. And if they were, then you had to find the equation from this. I know. It was like awesome. But, yeah, I know. Anyway, use the quadratic formula to find the zeros of f, find the maximum minimum. X-intercepts at 0 and 8. And the lowest point has a y-coordinate of negative 48. Oh, my gosh. I think I know what this does. Do you remember the last one? We had the x minus 1/2 squared, but we wrote it as 2x minus 1. How do you write an x-intercept, 8 and 0, and the lowest point? Does that make that a minimum or a maximum? What? The lowest point. Lowest point. Lowest point. Minimum. All right, so we got negative 48 down here at the bottom. We got 8. Now, I don't know if that's in the middle. Oh, it is. It has to be. This is 0, 0. This is 0, 8. How do you find... Oh, I sketched the graph inadvertently because I was trying to figure out what's going on. Wait a minute. You're not supposed to find the equation, are you? Yeah, it would be 8, 0. Thanks. Use the quadratic formula to find the zeros. Yeah, they are. And they already give you the minimum value. Well, that's no fun. I was going to find the equation. Let's find the equation. What do you mean? That ain't going to be fun. How do you... I want to find the equation. How do you find the equation? Oh, we got to find the equation. See? So in the book it says find the equation. So how do you find the equation? I've been showing you this all along, Alex. Yeah, you could. Yeah. Yeah, I think that's what you were saying, right, Alex? Find the midpoint? It is 4. What? Yeah, 4, negative 48. It's the vertex. See, you got lucky because it gave you the minimum point. They should just give you the x-intercepts. But anyway, yeah? You have to find the equation, then go back and find the minimum. I know. You remember? 4 is equal to the opposite of b over 2a, right? I know. I thought the same thing. But the x-intercepts, how do you write those? How do you write them as factors? How do you write them as factors? Oh, come on now. This is written as a factor as x minus 8. This is written as a factor of x minus 0. There's 2 ways you can do this problem. One way is to use this as h and k, x and y to find a, right? Okay, we can do that. F of x equals, what is it? Oh, a times x minus 4 squared plus a negative 48. And now I can put in x and y and find them. Obviously, it's pretty easy. I was just going to find it using the other thing, but that's okay. 0, I'm going to use I'm going to use the origin. So 48 equals 16a, so a equals 3. What form does it want it in? The standard, is that the HK? Okay, that's kind of boring, but okay. 3 times x minus 4 squared minus 48. Positive or negative a? Positive, perfect. Nice. How much time do I have left? Perfect. Am I going to finish?
No.
Oh. Yes, I am. Booyah!
I quit.
Skipped 1, I skipped 2. A farmer wishes
Quit.
to put a fence around the rectangular field and divide it into 3 rectangular plots. Why do you think there are 3 of them?
Make it better.
Yeah, so you can't just square it and be done. Square, you know, maximizes, minimizes. Okay, I know. And then divide the field into 3 by placing 2 fences parallel to one of the sides. The hardest thing about this used to be question number 5 in the old calc exams. They could never figure out the picture, how to draw it. A rectangular field and divide it into 3 rectangulars. There you go. No! Well, they were so hyped up from questions 1 through 4, they got to this one, they were just dead in the water. Anyway, by placing 2 fences parallel to one of the sides. I did that. If the farmer can only afford 1,000 yards of fencing, what dimensions will maximize the rectangular area and you disregard the fence? Dimension. I love that look of confidence. It makes me feel good about the lesson so far today. There's like 2 things going on, right? Perimeter. Don't worry, you'll get the hang of this question. You'll see it about 18 times. Well, that's because the kid wrote the book for the dad. He got this problem from dad. Okay, what's the perimeter mean? You add up all the sections of fence, it has to equal 1,000. The people that never listen start cutting things into fourths and thirds. They're in trouble. Keep everything as whole. 4 x's and 2 y's equals 1,000. We divide by 2, that's a great call. 2x plus y equals 500. How do you find the area of something? Length times width. You see why you want to keep x and y as whole numbers. You don't want to bring fourths or anything like that. X and y. And which one are you trying to find the maximum of? The area or the perimeter? The area. So that's where you want your squared term to show up, right? How can you make the area into something squared? Great. Make the substitution. X times 500 minus 2x. What dimensions will give the maximum rectangular area? So now the area is going to actually equal 500x minus 2x squared. That's a bad x. That looks like an asterisk. There we go. 500x. So, hey, how do you know it's going to be a maximum? Because what? Yeah, A is negative. So the x-coordinate of your maximum is going to be the opposite of B all over 2 times A. That's the x-coordinate. So 500 divided by 4 is 125. How do you find y? Yeah, you put it back into the equation. 500 minus 250 is 250. I love that. We'll probably do some more word problems tomorrow. So in your homework for tomorrow, go ahead and I think I got it broken up. There you go. Come here. So go ahead and go through 21. 1 through 21 odd. Okay? Then tomorrow we'll finish it up 21 through 55. There's some more word problems I want to do. Page 1. I like this thing. I'm going to start using it more. See, page 183. Okay? Thank you. That's the only way I can stay organized. That was fun.